In our last couple examples, we're going to use the converse of the Pythagorean theorem, but don't forget, the converse of the Pythagorean theorem only works if it's a triangle. Don't forget to check if it's a triangle at all. Make sure the two smaller legs add up to be more than the third leg. And so what happens, if I look at example 5, my two smaller legs are 7 and 14. 14 plus 7 is 21. That's bigger than 16. So yes, that is a triangle. So now I'm going to compare c squared with a squared plus b squared. C is going to be my biggest number. So I'm going to compare 16 squared with 7 squared plus 14 squared. 16 squared is 256. 7 squared is 49. 14 squared is 196. Well, if I add them up, 49 plus 196, that should be 247. Notice, 256 is greater than 247, so that tells me this will be an obtuse triangle. Let's take a look at another example, example 6. I've got sides of 9, 40, and 41. Does that make a triangle? Well, 9 and 40 is 49, so that's bigger than 41, so yes, that makes it a triangle. So now we're going to go through the same process we just did. I'm going to compare c squared with a squared plus b squared. C is your biggest number, so 41 squared. I'm going to compare that with 9 squared plus 40 squared. Well, 41 squared, I don't know what that is. I'm going to use my calculator for that. So if we're going to take 41 and we square that, we get 1681. I'll compare that with 9 squared is 81. 40 squared is 1600. So 81 plus 1600 is 1681. Oh, they're equal. So that tells me it's a right triangle. Remember, always double check to make sure it's a triangle first. If you don't do that part, you can't use the converse.